Ever tried finding a single detail in a 100-page document? Like searching for a needle in a haystack, but the haystack is massive and full of distractions. That's the challenge for AI models when dealing with long, complex texts. But researchers have just cracked a code to make models way better at this. Let me break it down. So why is this so hard? Imagine a student trying to answer a test question. If the textbook is just a few pages, no problem. But if it's thousands of pages, full of irrelevant sections, confusing diagrams, and repetitive content, the student struggles. Traditional AI methods try to train models to handle this, but it's like forcing the student to memorize the entire textbook. It's memory-heavy, inefficient, and doesn't scale. Enter PERK, a breakthrough that's like giving the student a smart notebook instead of a textbook. Instead of cramming all the info into the model's brain, PERK uses a lightweight tool called LoRA to temporarily store and organize the most relevant parts of the text. Think of it as highlighting key paragraphs or jotting down notes during a lecture. Only the essentials are kept, and the rest is ignored. Here's how it works. PERK has two loops. The inner loop acts like a quick scan, compressing long text into bite-sized chunks and storing them in the LoRA adapter. The outer loop then uses these notes to answer questions, learning over time how to prioritize the right information. Crucially, PERK doesn't retrain the entire model, just the adapter. This slashes memory use, making it possible to handle context 32,000 tokens long, that's like 20 books, without slowing things down. The results? PERK is a game changer. For smaller models like GPT-2, it boosts performance by up to 90% when handling long texts. Even bigger models like QN2, 5-0, 5BC a 27% improvement. And it's not just about speed, it's about robustness. PERK handles tricky scenarios where the needle, relevant info, is hidden in a sea of distractions. Unlike older methods, it doesn't panic when the question's context shifts. Think of it as a student who can adapt to any test. So why does this matter? Real-world applications, like analyzing legal documents, medical records, or scientific papers, require models to process huge amounts of text. PERK makes this possible without huge computational costs. It's a game-changer for AI that's both efficient and powerful. Next time you see a model handling a long, complex task, you'll know there's some smart science like PERK behind it. Stay curious, because the future of AI is all about solving these kinds of puzzles. Ever wondered how AI tackles a 100-page legal document or a dense research paper? Most models struggle with long texts, but researchers are cracking the code. Let's dive into how they're testing and improving AI's ability to really process long contexts, because it's not just about reading more, it's about understanding more. Imagine a model that can stretch its memory during processing, like a detective piecing together clues from a 100-chapter case file. That's the idea behind self-extend techniques. Papers like Maybe LongLM show this works, but it's not perfect. The model sometimes gets lost in the details, proving that context isn't just about length, it's about focus. But here's the catch, what even counts as a long context? Studies like Lost in the Middle reveal a big problem. Models often ignore the middle of long texts, focusing only on the start and end. It's like reading a novel, but only remembering the first and last chapters. This highlights a key challenge. How do we teach AI to truly read the whole story, not just skim it? Enter Jamba, a wild hybrid model that combines Transformers, the AI workhorses, with Mamba, a newer architecture designed for speed. It's like mixing a sports car with a spaceship. Jamba claims to handle long contexts faster and with less power, which could revolutionize everything from chatbots to data analysis. Of course, there's still a long way to go. Researchers are building benchmarks like Longeval and ZeroSCROLLS to test how well models grasp long texts, while others like Babylon push them to solve puzzles in haystacks of data. It's a race to make AI not just smart, but deep, able to reason, recall, and connect ideas across vast information. The journey to mastering long-context AI is just beginning. With innovations like PERK and Jamba, we're moving closer to models that can handle complexity without sacrificing efficiency. Stay tuned, because the next breakthrough could be just around the corner. Keep exploring, and remember, the future of AI isn't just about power, it's about precision.